Hello, this is Mr. Humbart here. For this video, we're going to go through this assignment over the Chapter 7, Section 3 assignment. So, for this assignment, we have 4 problems. And these problems aren't that difficult, they're just a little long. So as long as you know the general idea, it should be fine. So to start, we have this 88 kilogram astronaut, I'll call him M1, holds onto this large 1338 kilogram satellite, M2. Both are at rest relative to a nearby shuttle. So they're both at rest, they both have the same speed. So V initial 1 equals V initial 2, which is 0. And I know that the initial momentum for this entire assignment is always going to be equal to the final momentum. Then the astronaut pushes off the shuttle, giving it this speed. So V2 final, because it's the speed of the shuttle, directly away from the shuttle. The astronaut comes into contact with the shuttle 7.5 seconds after pushing away from the satellite. This is going to end up not mattering here. We want to know the final velocity of the astronaut. So, and he pushes the shuttle to the right. Let's set up our equation. So the first part, he's together, so 1 plus M2 V initial equals M1 V1 final plus M2 V2 final. Now I'll plug everything in. This is going to be 88 plus 1338 times 0, because they're at rest at first. That's going to equal 88 times V1 final. I don't have that, but I still plug it in anyway. Plus 1338 times 0.12. Alright, and then I should just be able to solve this out. So 0 over here is going to equal whatever this is. Then I'm going to have to subtract here this expression. So this is going to give me, I'm going to subtract 1338 times 0.12 to both sides. I will get negative 160.56, like that, 88 V1 final. And then I divide both sides by 88, and I should get negative supposed to be an F. Negative 1.8245, then on and on, but I only want 2 decimals, so I round that one down. I get negative 1.82. Alright, so for the second one, same type of problem. 2 canoes touching at rest on the lake. So we know the initial part's going to be 0. 0 equals, now we want to know the final part. Still using that same idea. If the initial is going to be 0, the final is going to be 0. So now, if they're going in opposite directions, we can just add our equation. like so. And now I'll put in my values. So canoe 1 has the speed of 0.72, V1 final. Canoe 2 has the speed V2 final, and they're going in opposite directions. I have to choose positive, negative. I'll go ahead and choose 2 as the negative. I could choose the other one as a negative also, though it won't matter. Mass canoe 1, so M1 is that. We don't know M2. Okay, so I'm going to set up my equation. Just plug everything in. So 0 equals 3, 2, 3. And this is 0.72 plus, don't know M2. I do know speed of canoe 2. 3, 6, and that's going to be a negative value. Alright, so I'm going to solve this, put this on the other side. So 323 times 0.72, 232.56 to both sides. And here, I'm going to simplify this, and M2 will be negative 232.56 divided by negative 0.36. The negatives are going to cancel here because they're divided. I should get 232.56 divided by 0.56. And looks like I made a calculation error somewhere. Times 0.72. There we go. And I get 646 on the dot kilograms. All right, yeah, this cannonball. Say that's M1. Shout out this cannon, M2. And we know the final velocity of the cannonball is this, V1 final. We want to know V2 final of the cannon itself because it's going to recoil backwards when it's shot. So we know it's initially at rest. So we'll have M1 plus M2 times V1 initial, which is going to be the same value for both because they're both at rest. That's going to equal M1 V1 final plus M2 V2 final, because P initial equals P final. So I'm plugging my values. I'll get 0 here. It's at rest first before it's shot out. Then afterwards, it's 11.9, 46.2 plus 672 V2F. All right. I should just be able to plug all these in. 11.9 times 46.2. 5 678, make that negative. Put on the other side, 672, V2F. I'm going to solve for that, and I should get divided by, so negative 549.78 divided by 672, 0.81825, but I want, that's negative, I want 2 decimals, so round this value. It's 0.82. All right, last one. So for this problem, we have 2 marbles hitting each other, and this is going to be an elastic collision. So it's a little long. I'll set it up here. So like before, the initial equals the final. We're going to use this equation. That's the initial. This is going to be the final. All right. First marble has this mass and velocity. Second marble has that mass and velocity. And that's initially. Then after hitting each other, the masses don't change, but the velocity of the first marble does to this. We need the velocity of the second marble. So we don't know this one. We know everything else. So I just plug in all my values, and I should get 0.31, 3.05 plus 0.37, negative 3.57 equals 0.31, same mass, now new velocity, negative 1.92 plus mass of the second one is 0.37 times mass of the velocity of the first or second one, which we don't have. All right. So set it up. Now, the quickest way to do this is to simplify everything on this side. So simplifying all my values. 1 times 3.05 plus 0.37 times negative 3.57. On this side I get negative 0.3754, sorry, equals, now simplify that, 31 times negative 1.92, negative 0.5952 plus 0.37 V2F. Alright. Now finally, I'm going to add this one over to both sides. And then once I do that, I will simplify again. I should get this equaling this. Divided by 0.37, and I should get a positive 0.594 meters per second. It repeats onward, but I only want 2 decimals, so I round that off here. So 0.59. And that's it. Have a good day.